Alright, on this. First one, what's this say when it says find AB? What's that mean? Find the length. You got to remember that when they don't give you the segment symbol. Find the length of AB. What are we going to use to do that? Distance formula.
Square root of parentheses x minus x.
So 6 minus a -2, which is 6 plus 2, right? Squared plus
7 plus 4.
7 minus a -4, which is 7 plus 4 squared.
Equals 13.6.
Does everybody agree with 13.6? List the segments in order. This one, on a lot of them that we did last chapter, you could just go through and say, okay, yeah, I know this one's bigger than that one. Now, smallest, this is a little harder because of these two. So I actually went through and found x, and I think x came out to be 10.
Yep.
How do I know, or what equation did I set up there? Excuse me.
3x plus 5 plus 7x minus 5 plus 7x plus 10 equals 180.
Three angles of a triangle got to add up to 180. Three sides of a triangle got to add up to 180? No. You remember me saying that before? Make sure you don't make that mistake. Still a few people on the test.
17x plus 10.
So 7 times 10 is 70 plus 10,
80.
80,
65. 35.
65, 35. What's that tell us about? Let's start with the smallest one. What's that tell us about that?
TH is the smallest.
That's the smallest side or the shortest side, so TH.
Then NH.
Then what?
NH.
NH.
And finally NT.
NT. Jacob, focus.
No.
That's not right.
No, if you go by the angle measurements, no.
NH would be the biggest. So it would be at the end.
Because 80. See?
Harry lied to me. Harry, I'm not even looking at you. You're lying to me just to make me look silly, aren't you? So those two are switched
Just because
around.
it looks long doesn't mean it is.
Exactly, and that's what, don't go by my drawing, right? On the test. Tell you what, let's do this right now. So you got some triangle. Got a 9-inch side and a 27-inch side. I gave you a point if you drew this triangle like that. I gave you a point because at least you were thinking. All right? I think right before the test I told you make sure you show all your work, even if you think it's silly, show it to me. Who knows? How do we find what that third side could be? You add them, and that's going to give you what?
36.
The high end, right? So we know the third side's got to be less than 9 plus 27, which is 36, you said?
Yeah.
Now, is that all we do?
No, then you do 27 minus 9.
You do 27 minus 9, and that gives you the low end. What's that?
18.
18. That's what your answer should have looked like. Now, I had people put this, and I might have taken a point off. Why? If I put that, what's it look like your answer can be?
18
Looks like it could be 18 and 36. Can it be? No.
The theorem says that the two sides added together have to be greater than the third side, right? So the third side would be, okay, never mind.
Does that make sense now?
I think so.
So if this
I
third,
was thinking the third side had to be greater than the numbers added together.
no,
But that's what
two sides got to be greater than
Okay.
the third side. So the two sides added together have to be greater. So if you wrote this down, it looks like 1836. I probably took off 1 point out of the 3 because that's not a real good explanation. If you wrote it out, the third side must be between 18 and 36. Then I gave you that. All right? Is that what your question was?
Well, I said like anything under 36, but it could be from 18 to 36.
So I probably took off, what, 2? Go ahead, Kenzie.
19.
You have to read it to me.
In the diagram of the formal garden, the east-west path is perpendicular to the north-south path, and segment AD is compared to segment
So find the one about the garden. The one about the garden, it looks something, the picture, I'm not drawing the garden, but the picture looks something like this. It's D there. They tell us those two are congruent, that's C. They tell us this is a right angle. First thing you should realize on this is segment BD is a what? And that's one of the things I wanted you to write. Got a point. If you wrote down segment BD is perpendicular bisector. Once we know it's a perpendicular bisector, we had a theorem. What did that theorem say about perpendicular bisectors? Any point that falls on that perpendicular bisector is equidistant from the endpoints of the original segment. That's the next thing I wanted. Any point on perpendicular bisector is same distance from the endpoints. And I was sort of not real critical about your grammar and your English, and because this probably isn't the proper way to state it, because but if you wrote something like that, I probably gave you credit. Then the third point would have came from, well, B is on that perpendicular bisector, so what do I know about this length and that length? So segment AB has to be congruent to segment BC or CB, I don't know, however they named it. 3 points. A lot of people figured out, hey, it's perpendicular bisector, and then they got to be congruent. So you got 2 out of the 3. Because I also want you to be able to tell me, how do you, since it's a perpendicular bisector, how do you know that they're congruent? Because any point that falls on that perpendicular bisector is the same distance from the 2 endpoints.
I put they're congruent, and then I have my reason, but you circled they're congruent. And you put a question.
All right, I circled there congruent because I gave you a point for that. And then try a question mark because your reason wasn't the reason.
All right, let's go.
Yes, Jade?
The one with the triangles and what's congruent? It says the stained glass.
The stained glass window one.
Yeah.
So find the one with the stained glass window. It's got triangles on it. Looks something like this. It's got that. It's got something that comes down here like that. Something like that, I think, right? That's Y. That's D. That's E. That's X. That's F. That's Z. They tell us that XD is congruent to YD. So what's that tell us about point D right here?
That's
It's a,
bisector.
give me a midpoint, all right? Bisector, it bisects, it's a midpoint. Then they tell us that XF is congruent to FZ. And they tell us that YE is congruent to EZ. So what's that tell us about these other 2 points? Midpoints also, what's that tell me about that segment right there? What's its name? DE, that's true, but tell me what kind of segment is it? Mid segment. How about this segment? What's it called? Mid segment. How about that one? Mid segment. All 3 of them are mid segments. What do I know about this mid segment right here and how it relates to that bottom side?
It's parallel.
It's parallel, that's true, and it's half of it, right? So let's look. The parallel. They wanted DE is parallel to what? So DE, that's one we were just doing. What's it parallel to? XZ would work. There's other ways you could have named that one. You might have named it XF. You might have named it FZ. Any of those. ZX, whatever it says. Then it said segment DY. Is that right, DY? And they want to know it's congruent to, and it's actually congruent to 2 other segments. So dy is right here. Well, one of the segments we know it's congruent to is what? Dx. They told us that, right? So dx. So we have this. What other segment's it going to be congruent to?
FE.
That one right there. That's the mid segment. That's got to be half of that. So FE or EF. Those are the two. Now, do we know that this one, a lot of people put this. Do we know that this one's congruent to that one?
No.
Might look like it, but did they tell us that? So we can't assume it. That answer?
Yeah, I put X value.
It's confusing.
Yeah. It says like find the value of each variable, and then it's like a triangle, and then it says V is the centroid of
Got it.
RST.
This one, I apologize for this one because it's a little hard to read, but your guys' eyes are better than me, so I figured you could handle it. Should have made it a little bigger, maybe. Find the one on your paper, it looks like this. And X is right here, that's that segment. Y is right here, it's that segment. And Z is here, it's that segment. They tell us that TP, so this whole segment right here, sort of hard for me to mark, but that, I'm just gonna take an arrow and point at it. That whole segment is 18. We had two different ways, if this is a centroid, we had two different ways to think about the centroid theorem. What do you know about this segment and how it relates to that segment? This is half of that one, right? That's half of that. That doesn't help us this time because they told us the whole thing. I mean, it sort of could, but we sort of got to use the other part, the 2/3 and the 1/3. We know that this, T to B, is 2/3 of the whole length, and this is 1/3 of the whole length. If we take 18 and we split it up into 3 parts, what's each number? All right? If this is 2/3, how long is it? It's 2 of those 6s, so how long is it? 12. If this is 1/3 of it, it's 1 of those 6s, so how long is it? So X is 6. That's one of our answers. Let's go over the other two. Let's see. They tell us that MS is 15. So this one that goes up through here is 15. Let's not do all that again so that we don't have to. This is 2 of the parts. That's 1 of the parts. This part over here is 10. This part is, so what's Y? They tell us this segment is 24. So how much would this longer segment be? 16. This one would be 8. Other questions? Go ahead, Jenna.
The one that find X and identity is K is altitude triangle.
I heard the word altitude. As soon as I hear altitude, what jumps into my head? Heights. Heights. It doesn't. That's not it. Because I'm not flying an airplane, so I don't care. Orthocenter, give me something else. Right angles, that's the one that should jump in your head as soon as you hear altitude. Anytime you hear altitude for the rest of the year, think of right angles. So they tell me HK, there's an altitude. What's that tell me about this angle right here? It's a right angle, it's 90 degrees. What's that tell me about this angle? 90 degrees. They tell me that this is X plus 8. This is X minus 9. That segment from there to there, there to there. I think this is I and that's J. And they tell me that this angle right here is 3x plus 3. Hopefully, because I had a couple people, not in this class I don't think, but the 3x plus 3 looks like this. I had a couple people think that it meant division. I've said that a couple of times, right? I'll never ever use that division sign that way. That's for when you were in 3rd grade, not high school. It's just because the printer's not very good. All right, so that's always a plus if it looks that way. It just doesn't print very well. What equation can I set up here? This is where most people messed up because they didn't know what equation.
3x plus 3 equals.
Can I set these two equal to each other?
No, you cannot.
It's not a median, is it? Can I set this equal to that? No, one's an angle, one's a segment. Can I set this equal to that?
No.
One's an angle, one's a segment. Can I add these two together and set it equal to that? Go ahead, Harry, tell me again.
It's 3x equals 9. Well, 3x plus 3 equals 9.
That 3x plus 3 should equal 90. You need to know that that was an altitude that formed a right angle there, so that angle had to be 90. Somebody divide that for me so that I can figure out what x is here.
X should be
X is 29. Anybody else get that? I think that's half our answer, right? What are we going to do once we know x is 29? So I plug it in right here. What's 29 minus 9?
20.
20. Is that my other answer? I need this whole thing, right? 29 plus 8? 37. What am I going to do with those two?
And together
You get 57. That's IJ. So you got, those are your two answers. What's the key idea that we use there? Altitude. Altitude forms a right angle. Key idea. What's the key idea that we used on the stained glass window one that we just got done doing a minute ago? Mid-seg. I know Lauren thinks I'm just throwing stuff out there because I like geometry stuff. How about the garden one? What was the key idea on it?
Equal bisector, perpendicular bisector.
Perpendicular bisector, and the fact that any point on the perpendicular bisector is equidistant from the endpoints. Make sure those get to where they belong in your binders. Again, at the end of class, we'll talk about something else. Something where maybe might give you a chance to earn a few extra points on it. Except for Ginger. She didn't need any extra points. She's a mathematical goddess. I'm going next test I'll have her stand up here and do this the whole time, all right?
I don't even know why you give her a head start.
Why, did she have a headache or something?
Looking at you, Ethan, yes, she would have a headache.
I get that a lot.
I know. Polygons, write this down. We got to move quick. Wasting too much time. I know that. So the title is polygons. What we're going to do, we're going to learn 4 formulas. Those formulas are going to allow us to find and use or find the interior angles of a polygon. And the other formula is going to allow us to find the exterior angles of a polygon. It's just that title. Make sure you know that title. Polygons. Polygons. What's polygon mean?
Many sides.
Many sides. That's all it means. Diagonal of a polygon. Diagonal of a polygon connects 2 non-consecutive vertices of a polygon. I'm going to put these up here. Didn't want to do that previous. Go that far. Write down the definition of diagonals there. If you want to draw the pictures, that's great. Go right ahead. If you don't, your notes.
You're not going to be heartbroken by it?
Nope. Let you use the binders on this last test. And this class isn't too bad, but some of my other classes, I'm thinking, you know, if you would have wrote that down, you would know that any 2 sides add up to be more than the 3rd side.
You know, I'm surprised I still don't have my binder.
I'll tell her.
Actually, no.
You have the wrong definition of polygons.
Many sides.
No. Polygons.
She's got something
My
fun.
parent left. Yeah, they're gone. I did not laugh at you. I glared at you.
All right, Ginger, if Alyssa didn't think that was funny, boy.
That's why I think it's funny. It's because she doesn't like it.
Ginger, don't worry. She just practiced.
We talked about diagonals earlier this year. So watch up here. A diagonal of a polygon connects two non-consecutive vertices. So if I drew some letters here, A, B, and C, that's our triangle. Name me two non-consecutive vertices in that triangle. Thank you. There are not any non-consecutive vertices in a triangle. So a diagonal or a triangle has how many diagonals? It's got no diagonals. You can't draw a diagonal in a triangle. Now we go to a quadrilateral, which is a four-sided figure. If I put some letters on it, A, B, C, and D, name me two non-consecutive vertices, two non-consecutive corners. AC. So I could draw a diagonal from A to C there. All right? And name me two other ones. BD. Oops, I didn't put BD in there. So I could have drawn one from here to there also, right? Now, a lot of times, what we're going to do today, and what you did on that the worksheet that had the crossword puzzle, which I forgot to go over, we'll get to that here in a minute. We'll turn that in at the end also. We don't want to draw in all the diagonals. We want to draw in just the diagonals from one corner. All the possible diagonals from one corner. And that's what I did here because, and we talked a little about this in one of the other chapters, because when I do that in a quadrilateral, what's formed? Two triangles. And we said that makes it stiffer, right? Makes it more structurally sound, stronger. So a lot of times that's what we want to do. So if I pick one corner in this picture, how many diagonals can I draw from just that one corner? Two?
3.
Let's try it and see. So if I pick this corner right there, that's one, right? What's the other corner I could connect it to? That one down there? How about this one? It's already connected to it, isn't it? So let's see. So that's all of them, isn't it? So here we had one, here we had two. What do you think is going to happen if I had a six-sided figure up here?
3.
There's going to be three diagonals from that one.
Why can't it has to be just one?
This would still be, so what Ginger's asking, would that still be a diagonal? Yeah, that's still a diagonal, but if we're just trying to make it like we were before, where we want to just be structurally sound, we want to split it up into just the triangles. We don't want to make it any more than complex than it has to be. Does that make sense? So how many triangles do we have here?
3.
3. What do we know about the three angles, the three interior angles of a triangle? They add up to 180. So we know that all those angles inside there are 180. We got a triangle here, we got a triangle here. This triangle, what's the three angles add up to? 180. What's the three angles of this triangle add up to? Guess what all the angles in that quadrilateral add up to? 360. I mean, this triangle adds up to what? 180. 180. 180. What's 180 times 3?
520.
Close. 540.
They really just get that right.
Now, the reason that, to explain to Ginger, the reason that we don't want to add in this as a diagonal, notice here, when I put this diagonal in here, did I add any new angles to the picture? These two angles add together still give me that original angle. When I throw in this diagonal, you see these angles in here? Now I've added new angles that weren't there originally. So the math gets messed up. Does that make sense? So now, the lovely and talented Alyssa, she has this five-sided figure here that's a little puzzle. Hold it up so everybody can see the whole thing. And hold up the pieces. She's got a five-sided figure. She's going to fit those triangles in there. It might take her the whole time to figure out how they go in there. She's going to fit those triangles in there. What do we know about that first triangle that she just put in there? 180 degrees. What do we know about that second one she just put in there? 180. What do we know about the third one? 180. Did she add any new angles to the original shape, which was a pentagon? Guess what? Every pentagon in this world, no matter what it looks like, guess what all the interior angles got to add up to be? 540. Quadrilateral, any four-sided figure that I have you draw, guess what it adds up to be? 360. Anybody guess on a six-sided? Don't break money. Anybody guess on a six-sided what they're all going to add up to be?
720.
720. What are you doing there? Seven-sided.
Add 180.
Add another 180, right? Add another 180. Could we go all the way out forever and ever and ever and find out what a 100-sided figure is going to add up to on the inside?
1,080.
Yeah.
It's not even like the shape. Like, it's not even.
It is.
It's not.
Oh,
It's all lopsided.
it's not supposed to be. It's a pentagon. Does every pentagon have to be the same on all the sides?
No.
No. Does anybody remember what's it called if it's the same on all the sides and all the angles? Starts with an R. That's could be. And we're going to talk about it here in a minute. See, now I drew in all those. See all those extra that we have there? Didn't want all those there. All right, polygon interior angle theorem. Polygon interior angle theorem. This formula, I'm going to write this down right here. Sum of interior angles. That formula is the most important thing this section. N minus 2 times 180. If that formula confuses Peyton, I've been suggesting the last few years to maybe do this. Move the 180 out in front. Because that looks more normal to you, right? When you have something on the outside of the parentheses, where's it usually at? On the front or on the rear end? The front. So if it looks more normal to you, move that 180 out here. What's that 180 on the outside tell us that we're going to do with it? Multiply it by whatever's inside the parentheses. N stands for the number of sides in whatever shape it is that you're dealing with. We already know a triangle. What's the three angles? The interior angles of a triangle always add up to equal? 180. So we know that. All right? What would I put in place of n here if we were dealing with a triangle? 3, because it's got 3 sides. So 180 times 3 minus 2. What's 3 minus 2?
1.
What's 1 times 180? What do we know about the 3 angles in a 3-sided figure? They always add up to 180.
So if we had a 12-sided.
If we had a 12-sided figure, we could do 180 times 12 minus 2. What's
180 times 10.
that's 10 there, so 180 times 10, 1,800. So any 12-sided figure in this world that we draw, we know that how many angles is a 12-sided figure going to have? 12. It's got the same number of angles as it does sides. Any shape's that way, all right? 15 sides, 15 angles. If we got a 12-sided figure that we draw, I'm not drawing a 12-sided figure, so sorry about your luck. I'm not doing that because what would my 12-sided figure end up looking like? A circle. Right? But any 12-sided figure we draw, we know that all 12 angles are always going to add up to 1,800. Next one, the exterior angle theorem. Exterior angle theorem. This is the hardest theorem that we're going to ever have all year long. Next test, there'll be about 30 of these questions on there. I'm going to say, find the sum of the exterior angles of a 57-sided figure. Make it just completely and totally difficult on you.
Going back to algebra.
Huh?
Kidding?
No, going back to algebra there.
Were you kidding or are you being serious? Kidding?
Write it down. And then you'll know. It's easy. I'm going to give you a minute, and then I'm going to ask somebody, what is the sum of the exterior angles of a 57-sided figure? Yes, Ginger, I'm going to ask you. That way, if you get it wrong, that might make everybody else in here happy because you missed something.
I would bet.
know who they're not.
I may just be stupid at that.
How many exterior angles? I got a 1, 2, 3, 4. I got a 6-sided figure up there. Anybody know what a 6-sided figure is called? Hexagon. So I have a hexagon on the board. And I drew those exterior angles. Does everybody remember what an exterior angle is? It's one of the sides extended straight out outside the shape, right? So this is an exterior angle. That's an exterior angle. So on, all the way around. I drew all those exterior angles. How many exterior angles does the hexagon have? 6. How many interior angles does it have? 6. How many sides does it have? Those are always all the same. All right? 6 sides, 6 angles, 6 exterior angles. All right, $1 million question. Somebody tell me, what's the sum of the exterior angles of a convex polygon that has 57 sides?
360.
360. What's the sum of the exterior angles of a convex polygon that has 1,253 sides? 360.
Is it always 360?
Yes. What's the sum of the exterior angles of a triangle? 360. What's the sum of the exterior angles of a dodecagon? 360.
You don't even need to know Mr. Ebersol. Not to be a pain or anything, but that's a heavy.
What is it?
Yeah, there's 7 angles, there's 7 sides.
Oh, did I count wrong?
I'm thinking there,
My fault, I counted wrong.
Still 360 though, guys.
Still 360 on the exterior angle.
You really scared me, dude.
Now, the other statement that I made here is one, probably shouldn't have put it on this slide because I don't want you to get confused. If you're looking for the sum of the exterior angles of any polygon, what's it always going to be? 360. Right? I put this on here, and this is something you should already know. What do I know about that angle and that angle together? They're always going to add up to 180. How about these two?
180.
They add up to 180. These two, 180. So on, so on, so on. So don't forget that.
the sum of all
Always. There is. That's the formula. You don't have to plug anything in. It's always 360. So if you guys were talking about a second ago, or Alyssa was saying, well, if it's got all the same sides, if all these sides were the same, and we're going to talk about what kind of shape that is here in a second, and all the angles were the same, could we find each one of those angles separately? What would we take? 360, if all those exterior angles were the same for this shape, which they're probably not because my drawing's probably not very good, what would we do to that 360? Divided by the number of sides, 7. All right? We could do that and we could find each of these angles. But that only works if this shape is perfect. All the sides are the same, all the angles are the same. And we're going to learn that name here in a second. Which question, Peyton?
So no matter what, it would still be a septagon, regardless of if the sides are equal. That's just
Right.
another term for 7 second figure.
Right. So even though my pentagon here, all the sides aren't the same length, and I made them so that they wouldn't be because I didn't want it to, because every time I do something like this, that's what everybody thinks. Oh, all the sides always got to be the same. No, they don't. It's just got to be a 5-sided figure to be a pentagon. All right?
Just like a triangle.
Huh?
A triangle has different.
Right, just like a triangle. So triangle, when we did triangle, we had, with triangles though, we actually had different names for each one, right? Like this was a right triangle, or this was a obtuse triangle, or something, you know, whatever. We don't have different names for this, we have one name, sort of.
You also do that for 4-sided figures.
Right.
Why do they get special treatment?
I don't know. I guess somebody liked them better. Convex, anybody remember what convex is? What was the other word that goes with convex? Concave. How often do we deal with concave figures? Not very often. Concave, if you wanted to write that down, remember a concave figure is a figure that has an interior angle that's more than 180 degrees. Concave figures don't fit any of these formulas. That's why we don't deal with them. Right? So it'll say convex. Just about the whole chapter will say convex. We're dealing with convex polygon. Right. Anybody remember now if a shape's got all the same sides and all the same angles, what it's called? It's regular. It's regular.
Regular.
Now, we didn't call triangles that because triangles, again, were special. They had a special name. What was a triangle called that had all the sides the same and all the angles the same? Equilateral, equal angular. Could we have called it a regular triangle? So if Izzy wanted to be annoying next test and I put a triangle on there and I say, what kind of triangle is this? And it's supposed to be an equilateral triangle, and she says it's a regular triangle. Could I mark that wrong?
No.
Unless I just wanted to be mean.
If I put paint triangle, would I get it wrong?
Put Peyton triangle? Immediately. Oh, is that, did we let you say that?
Because I was asked, why do we need all these different names? But for a triangle, if it's equilateral, it has to be equal angular.
And for other polygons, it doesn't have to be. And that's
So
what,
that's where the distinction is.
that's where the bottom comes in. So a triangle, if it was equilateral, it also had to be equal angular. But for other shapes, it doesn't have to be. An example, if you go on a baseball or a softball field, you have home plate. Is this, what kind of shape is that, first of all? What shape is home plate? Pentagon. So it's, we have this pentagon. Is it regular? No. Is it equilateral? Does anybody know what's true about all 5 sides in that pentagon? They're all 10 inches. Are all these angles the same? No. These 2 angles are actually bigger than the other 3. Anybody know what these other 3 are on a home plate?
90.
They're all 9. Those 2 are 90. That's a right angle also. Could we find these 2 angles? Yeah, we just said, what's all the angles in a pentagon have to add up to?
560.
540. We know that this is 90, that's 90, that's 90. How much is that? 90 plus 90 plus 90. 270. What's 540 minus 270? What is it? 270. Does that mean this angle's 270? Those 2 together are 270. So what would we do to that? Divide by 2, 135. So if you go out on the softball field and you measure this angle and you measure that angle on the home plate, they should be 135 degrees. So a polygon could be equilateral, that's where all the sides are the same. Could be equal angular, all the angles are the same. If it's both of those, then it's called regular. It's a regular polygon. What's a regular 4-sided figure?
Square.
Square. So on next test, if I put you have a regular quadrilateral, you know I'm talking about what shape? A square. Does that sound like something I'd probably do? Instead of just calling it a square, make it a little harder on you and say you have a regular quadrilateral? Yeah, I'd probably do something like that.
What, the words in blue is that triangles must be fit. Can't they be either all sides or?
In a triangle, if all sides are congruent, then you also know what? All the angles are congruent. So if a triangle is one, it's got to be the other one. But for the rest of the polygons, it doesn't work that way. It could be one without being the other. Give me a shape, give me a 4-sided figure that's equal angular, but not equilateral. A rectangle. What do you know about all 4 angles in a rectangle? They're all 90 degrees, so it's equal angular. In a rectangle, do all 4 of these sides have to be the same? So it's equal angular, but it's not necessarily equilateral. give me a four-sided figure that's equilateral, you guys said this name earlier, equilateral but not equal angular. A rhombus. A rhombus. So one or the other, sometimes it might be both. If you do have a regular or equal angular polygon, then we can find each angle, whether it's an interior angle or an exterior angle. And these are the formulas to find each angle, each interior angle, each exterior angle. So we have 4 formulas. Notice, you seen that top formula anywhere before? Yeah, earlier on another slide, right? Except now what are you doing? Dividing by the number of sides. So you just find the sum of the interior angles, then you divide by how many sides there are. So you find the sum of all the interior angles, then you divide by how many sides there are. Bottom one. Same idea, right? What's the sum of the exterior angles of a dodecagon? 360 all the time. So we just divide that by the number of sides, and that would tell us each exterior angle if the shape, if the dodecagon happens to be regular or equal angular.
Shape names are weird.
That's what we're getting ready to do next. So everybody got that much?
Could you call a triangle a trilateral?
Yep. Peyton likes being different.
Well, because they're called quadrilaterals. But maybe they should be changed to quad A, quadgons. Trigons, quadgons.
So Peyton brings up a good point, because if you go down to a 3rd or 4th grade book right now, you've got triangles. They're trying to do away with quadrilaterals. Guess what they're calling them?
Quadgons?
Quad angle?
Quadrangles. And what's that telling you? That it has 4 what? 4 angles. Just trying to make it more uniform. So if somebody sees a triangle, know, hey, that's got 3 angles. Quadrangle has 4 angles, so on and so on.
But it just doesn't sound so nice.
You're just not
So you
used
could
to it.
also say
Now,
hexangle.
if you were in 3rd grade now and you heard that word, you might not have any idea. It sounds just fine to you, because quadrilateral probably didn't sound good to you when you were there. These are all 4 of those formulas. You don't have to write these down again. You already got them. If, listen closely, this is for all polygons. If you're just trying to find the sum, you got to be able to distinguish between these. If I say find the sum of the interior angles, know which formula you are using. If I say find the sum of the exterior angles, know which formula you're using. If I say you have a regular polygon, find each interior angle, know you're using this formula, so on and so on. So every problem, somebody's going to get confused probably. All right? Because you're going to, I'm going to say find each interior angle of a regular pentagon. And somebody's going to write down 540. 540 is the sum of all them. If we want to find each one, we got to divide then, right? So make sure you use the correct formula. You read the problem carefully anytime you're dealing with these. All right, draw this. I don't care how you draw it on your paper.
All in no way that.
3 sides. You already wrote it down once. 3 sides. Put the name. We're going to fill in the sum of the interior angles, sum of the exterior angles. If it's regular, what each interior angle is, what each exterior angle is. I don't care how you get it there on your paper. You do whatever you need to do to make it make sense to you.
Do you like winter?
Yeah, it's all right.
Well,
I like fly.
you're stuck in another 6 months or 6 weeks of it. Stupid ground.
that I'm too concerned about that, considering that over the last 35 years, he's been right 5 times. That's what it is. I heard it on the news yesterday that over the last 35 years, he's been right 5 out of the 35.
Do we write all that down? Do we
Who's been right 5 out of 35
make a
times?
table?
Groundhog.
Sonic Phil, whatever you.
I call it Phil the Most. I think it's, I still don't understand.
I think it was,
That's it.
I can't remember where it's at, but someone doesn't actually have a groundhog, they actually use a hedgehog.
Date. Okay, you know what,
Three-sided polygon, what's the name for a three-sided polygon?
Try.
Triangle, you know the sum of the interior angles? 180, so you could fill in those. Four-sided polygon, what's its name? Give me a better name, I don't like that name. Quadrilateral, that fits all of them, right? Not just, you're being prejudiced if you just say a square, you're just talking about squares and not all. Or quadrangular.
I forgot the number.
Five-sided, what's that name?
Pentagon.
Pentagon. Six-sided.
Hexagon.
Hexagon. Seven-sided.
Heptagon.
Hepta or septa, either one. Eight-sided.
Octagon.
Octagon. Nine-sided.
Nonagon.
Nonagon. 10-sided.
Decagon.
Decagon.
It's just like
12
Spanish.
is
Does anybody know a 12-sided? I said it about 3 times already today.
Dodecagon.
Dodecagon. Guess where dodecagon comes from? What's do mean? 2. What's deca mean? 2 plus 10 is 12.
One of my favorites.
What was 9 plus 11?
Huh?
What was 9 plus 11?
We didn't do 11. I skipped it. I don't like it.
Okay, well,
What is,
if you want to start us down, I'm not
What
writing
is
it down.
11?
I want that to be like, because I don't even have that laugh.
You guys complain too much. I didn't do that. I was way back there. You know I didn't do it. I didn't walk in the back room. I'll give you a couple minutes to write each one of these down. Again, sum of all the interior angles, sum of all the exterior angles, each interior angle if it happens to be regular, each exterior angle if it happens to be regular. Notice over here, N. N stands for what? Number of sides. So we were talking about a 57-sided figure a little while ago. Guess what we'd call it?
57.
57 gone. You just put in the number and put gone behind it. So we'll do a lot with that because not everything's going to be one of these. All right? And we don't want to have a name. We could come up with a name for every single one of them using something like dodecagon. We don't want to do that. That's too much to remember. So if it's got more than 10 sides, usually we don't even use dodecagon. If it's got more than 10 sides, we usually just call it, if it's got 15 sides, we'll call it a 15-gon.
I like the non.
So what else could we call a triangle then?
A 3-gon.
A 3-gon.
That sounds so.
It does. It sounds ignorant because you're not used to it, right? So we probably wouldn't do that. And if you put 3-gon on the test, when I ask you to name a triangle, I'd probably mark it wrong.
Technically, is it wrong?
Not technically. But for Mr. Eversole, is it wrong? Yes. And who grades your test?
You
But
want to
why
get
do we have to use the Latin, like, words anyway? Who decided that? They were just like,
This is right.
like, oh, that sounds smart. No one knows what it means, I'll use that. They used it so they could make up any rules they wanted.
Oh, for septagon here.
For what?
What else did you guys say?
Heptagon.
Heptagon. Heptagon. Either one of those is acceptable.
Septagon.
Heptagon or septagon. They changed it to septagon a couple years ago. How come? Because it's 7, so the S's went together. Maybe make it a little easier for everybody to remember.
I think they should quit changing stuff and leave it the way it is.
Does anybody know what the prefix septa means?
7.
7. What's the prefix hepta mean?
6. So.
7. They both mean 7.
You can even see it in the months, they'll be added to, so now it's not right.
And that was, see,
What's 11?
Peyton's screwing up my,
What's 11?
it doesn't have a name. Peyton's screwing up all my vast knowledge that I have by telling you before I can get to it. So, deca, what's the prefix deca mean? 10. Why is December the 12th month?
Because they added that month.
We added 2 months because they finally figured out a couple thousand years ago that, hey, it takes how long for the Earth to rotate around the sun? 12 months. So the calendar used to be 10 months, and when it was 10 months, one year, January would be very, very cold, then 5 years later, January would be very, very hot. September, October, November, December, all those got changed.
Yeah, when it is added to the very end to keep it.
Yeah, that I don't know. That does seem like it might have made sense. Huh?
Oh my. Yeah, it would have kept right.
See, that's the problem with using all these number roots. Because no one even cares what they mean.
Should. That's sort of the same reason that why do we still have, if you look at your computer and it's still got that keyboard, why is the keyboard the way it is on a computer?
What is that frequency of letter use?
It's the frequency of letter use for a typewriter. All right? Because old typewriters used to have these little bars. You would hit the button for the letter A, and a little bar would flip up and print the little A on there. You'd flip a button or hit a button for the letter N,
Hey, you should do it, not got you.
and it would flip up. So if you put those letters like A and N close together, letters that you use all the time,
They're gonna smack into each other.
they smack into each other, and guess what happens? On the old typewriters,
They
they
get
would
stuck.
stick there, and you'd have to go in there and separate them, and that'd slow you down and everything. So that's why they separated those letters, and we have the, what is it, QWERTY or something like that? QWERTY setup. So we have that QWERTY setup. Does that matter anymore?
Not really.
Why didn't we
Because
change?
when they do it with the
Because it's
ABCD
muscle
setup,
memory and then they throw it
Because now we've got it that way, and everybody knows it that way. So why change it now? That's the same thing with the. How close are we?
I'm at
I'm
8.
at the last one.
Did that say 3 7s 51 and 1?
But I can't really see.
3 7.
And I kind of.
So move up. You pick the seat.
That means you just sit in the front. And I can't.
I mean, at least we actually have numbers.
And means
The
you
real
join
one
the
is
company.
not CCC, XCC, XV, DDB,
Which of these, you can probably look at these and sort of decide which shapes do we not use a whole lot?
Septicons.
Septagon. How come?
Because it's fractions.
It's got these fractions in it. When you go to make a septagon, it's got those fractions in it. That's too much trouble. So we usually, out in the real world, how often do you see a septagon? Not often. How about octagons? You see them anywhere? Yeah, you probably see them every day. We're at stop signs. A nonagon. Do we use nonagons very often?
No.
No.
Because they're not.
Nobody likes.
So out of all these shapes, is a triangle the strongest?
Strongest as far as support goes? Yes.
So more is not mine's better.
Is that why the polygons are based off the triangles?
Have you ever seen a triangle roll down a hill?
Well,
Never
who's
see a
fast enough
screwball
enough
screw
to
down.
Yeah, but how about
What if he had 100?
You
Yeah,
get
100
it,
guy,
you
he'd be
get it,
like,
go
dude,
down.
you don't
I think you go-
How close are we? Everybody got it?
Keep you pumping, but it-
Yes? On the worksheet, get out that worksheet that you grabbed. We're going to do a few of those problems. We got about 10 minutes. Somebody tell me when it's quarter after. 15 minutes. Or 15 after.
You know, I want to reinvent the wheel, but as an
I don't think I know.
The worksheet that you grabbed up here, you can stick this in your notes if you want. As part of your notes, we're going to do a few of these. I'm going to try to move very quickly, so you got to follow along, listen closely. Have your calculators out to help me. If we get stuck on a problem for more than a couple seconds, I'll skip it and we'll go on to the next one.
Wait,
We're trying to find x right there.
I'm supposed to do this now.
No, hang on to that. I know it's got the holes punched in it, but I punched holes in it so that you wouldn't lose it. What kind of shape do we have right there?
Quadrilateral.
A quadrilateral. What do we know about the interior angles of a quadrilateral? They add up to 360. Hopefully that's one that you start to know without having to use the formula, right? Four-sided figure has to add up to 360. We know 3 of these. How could we find that 4th one? Add them. Tell me what to add. 127 plus 90 plus 40. Somebody add all that up for us.
It's 257.
257?
All that's left.
247? 257? What do we do with that 257? Does that mean that angle's 257?
No.
Subtract it from 360. What's that give us?
103.
So what's x up there? 103, 103 degrees. Next one, what kind of shape do we have on the next one? Pentagon. Anybody know what's the 5 angles of a pentagon? 540.
I don't have that.
Crap. So 540. So tell me an equation we could set up here. Let's write this one out as the equation since it's got a couple x's. Grab all 3 of them there. Also. Tell me what we could write.
540.
We'll do that at the end.
150 for the pentagon.
150 plus 102 plus 84 plus
3x?
2x plus x, which is 3x, right?
Yep.
And that should all total up to equal how much?
540.
540. Somebody add all those for me. 336 plus 3x equals 540. Now what?
Subtract 336.
Subtract 336 on both sides. You end up with 3x equals
204.
204. Now what?
X equals 60.
Divide by 3. X equals what?
68.
68. What they just said, find the value of x, right? So how much does x equal?
68.
What if they ask us to find the angles? What would we do?
Plug it in.
Plug back into those 2. One of them 68 and the other one is 2 times 68, which is 136. Next one. Let's see. Yeah, we'll do number 3. Number 3, what kind of shape do we have?
Pentagon.
Pentagon. What do we know about the 5 angles of a pentagon? 540. Remember, it's n minus 2 times 180. What's n this time? How many sides do we have? So you plug in 5 right there. 5 minus 2 is 3. 3 times 180. I'm hoping pentagon, 3-sided, 4-sided, 5-sided, you start to just know, right? Maybe a 6-sided too, without having to plug into the formula every time. This time they tell us that these 2 are congruent. This is 88. This is 130. This is, how much is the angle Z here? 90. Somebody add those 3 up for me.
308.
308. What are we going to do with that once we get 308? Subtract it from 540. Notice I'm not even writing out the equation this time. Just make it easy on yourself. What's 540 minus 308?
232.
232. What are you going to do to that? Is each one of these angles 232?
Divided by 2.
There's 2 of them, and they're the same, so we divide it by 2. What do you get?
116.
So this angle's 116. What's this one?
160.
116. Those would be your 2 answers. Number 4. How many sides on number 4? 6. Anybody know what a 4-sided or 6-sided figure? 720. We know that one's 100, another one's 100, so what are we going to subtract off there? 200. What's that give us?
520.
520. We know that the other 4 angles are all congruent, so what are we going to Do the 520. Divided by 4. Somebody do that for us.
130.
130. So what's each of those other 4 angles? 130. Number 5. Mr. A's plain as blue. Number 5. What do we know about the exterior angles? They all add up to 360. Do we even care that it's a pentagon? Doesn't make any difference. Exterior angles always add up to 360. So let's start adding. What's 92 plus 86 plus 70?
248.
248. So we're going to subtract that off, right? What's that leave us with?
112.
What do they tell us about the other 2 angles that they didn't give us? They're both x. They're the same, right? So what do we do with that 112? Divided by 2. What do you get?
56.
56. X is 56. Look at number 7. We're going to skip number 6. I don't like it. Look at number 7. It says find each interior angle and each exterior angle of a regular 24-gon. How many sides does a 24-gon have? 24. So we want to find each interior angle, each exterior angle. Easiest thing to do, first thing, we got to figure out what all the interior angles add up to be. We're going to do that 180. Does it bother anybody that I keep switching to 180 back and forth from the front to the back? Does that matter? Don't let confusion. 24 is n minus 2. Somebody do 24 minus 2 for me. 22. You take that times what? 180. What does that give you? 3,960. So how many angles does a 24-gon have? 24. All 24 of them add up to be how much? 3,960. How do we find each? What do we do with that number to find each one if they're all the same? Divide by 24. Don't make this harder than it is. 165 degrees. So each interior angle of a regular 24-gon is 165 degrees. Now I'm going to tell you this. Instead of, let's do this. We know the exterior angles add up to be how much? 360. How many sides does our shape have? What's 360 divided by 24?
15.
Amazed that I knew that, right? What do I know about an interior angle and an exterior angle? Together they got to add up to be how much? 180. So did you really have to do both of these? No. Which one was easier, this one or this one? So you might want to write down there somewhere in your notes, find each exterior angle first, because it's easier. Find each exterior angle first. It's easier to find the exterior angles than to find the interior angles. And then if you find an exterior angle and you know it's regular, all you got to do, we found this exterior angle, all we got to do to find each interior angle is subtract from 180. Number 8, 12, 15, this last one. Number 8, watch, this one's a little harder. Each exterior angle of a regular polygon has a measure of 18 degrees. So 18 degrees, that's each exterior or interior? Each exterior. This is each exterior angle. Equals 18 degrees. Whether they tell you interior or exterior, I would always go back and find, if they tell you interior, go back and find the exterior angle by subtracting from 180. Because it's going to be easier. We know that each exterior angle should be 360 divided by n. Well, this time we're saying 360 divided by n equals 18, right? Nobody likes the fractions, right? So what if I do this? Everybody likes these. Now we cross multiply. What? 18n equals 360. What's n equal?
N equals
20. So how many sides does this shape have? When you go to find n, last thing here, when you go to find n, if it doesn't come out nice and even, a whole number, You messed up somewhere. Because n is the number of sides.
You can't have like 20.3.
You can't have 20.3 sides. It doesn't work. Write this down. As you're writing this down, I'm going to explain the other two papers that you got. On those other papers, so that you can get some extra points if you want to do this on your test. And it's due in to me by next Friday. Next Friday. So extra points on your test. This sheet gives key concepts that we covered in Chapter 6. The first one says centroid is a point of concurrency of the three medians of a triangle. Then another one down here, longest side of a triangle is opposite the largest angle. Those are all key ideas that we covered, right? What I want you to do, this is a copy of the test, but it doesn't have any of the multiple choice or anything on it. Everybody listen to this so you understand it. Because some of you are going to be mad at me when you turn it in and you don't get any extra points. I want you to look at number 1 and tell me which key concept off of here, write it down. Notice I didn't number them, so you can't just put 1, 2, 3, 4. You got to actually write out the key concept right here. The median of a triangle is such, so on, so on. Write it out for each one. Does that make sense? You're picking one of these off of here. You're picking one of these off of here and writing it for each problem. What key idea do you need to use to solve that problem? You don't. There's no answer. The answers are all right here.
So what if I don't need up to how many?
Yeah. I'm not sure. Maybe 24. I think that's how many problems. Maybe. I'll see.
Ginger, my 25% chance is correct. How was it? I told you there's 25% chance that we won. There's a 75% chance.
I guess you were pretty good.
You're gonna add it?
Hey, Eversole.
What's that?
Returning,
She just asked me. Remind me next time.
all right.
Hey, you want me to grab that hair?
If you did, you would have been.
Yeah, please. You gonna turn any of this stuff into me? You pack it. Get it in, right? I'm getting ready to send the letter home. Remember I said that. Give me something good to say.
Contacts in the morning. I was like, hey.
I think you said when 202.
I'm sitting there on some.
Is that what you said? Room 202? What you said?
George!
You said room 202. No, that's what you said during this time.
Okay.
I got it now.
Alright, what do you want?
I might have to write it
Study during his time.
I had to write it.
Look at the cameras.
I'm gonna write it down. A lot of good and a lot of
Oh.
Wait, what happened?
Yeah, John cussed out with his old cousin. Yeah, he was like, when it was like, hey, put away your head, put away your earbuds. He's like, no, F you, mother effer, and walked out.
I don't know. I
Dude,
did
it's
that.
like I have a big pimple.
Yeah, Will was just like really calm it.
It does.
Earbuds away.
It really hurts. I don't know. I tried squeezing it and that came out, but it really hurt. I think it
Your
might be
jeans
a
are like half gone.
My mom bought them for me.
That's dress code.
They didn't even ask for them. She's like, there's some jeans by the front door. I'm like, okay.
I feel like John.
See, it looks like a pimple.
I get to take it off.
Doesn't it?
Oh wait, no I don't.
I'm surprised I'm like
Why do you
I know, but
Man's not hot.
Kids, you guys want to
Man's not hot.
your shirt's still
Man's not hot. Man's not hot.
Oh, that video.
Man's not hot.
Because he got a blue jacket on and said, man's not hot. Put me on the Twitter. tucking my shirt in.
These are those.
No, it's like, you have like the vest, and then it's like your shirt.
You can only do deep 53.
Actually, I like shirts like that.
That hang out. I hate
I love it.
Yeah, I know. Same.
I especially got that like that. I mean,
and then a D. Yeah, no, it's like
not sure.
A, B, 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 D. Yeah, exactly. And it's like, what is this?
Hate when people wear like hoodies and then their shirt like
You know what?
hangs
I know
out.
I got way better.
I hate when people like wear hoodies and their shirts.
I'm not scared of you. You what now?
Yes, I guess I'm like,
What now?
Oh, he's gonna do it just like
Oh,
that.
hey.
I'll put you dead like you.
I ain't heard that bad.
Look at that.
That's all chapters. It's very much.
What are you going into that art?
What?
What are you going into that art?
Down water bottle, I got my password. Jeremiah's throwing it down, Lord. And he said, turn down for what?
You have last one? Yeah. I know. Wear contacts.
I don't want to take it anymore.
This one.
We still have like chapters to go, and then I think I might have too much wine.
Catch me out there next tomorrow.
I ain't talking to no, I'm like.
Why?
Look, so George, where did you get that paper?
This?
Mr. Sherman? No, actually, we were in this.
Oh, Miss Dad, did you need one? What did you do? Oh, I thought there was
Or ask Mrs. Gray.
Hey, do we have any?
No, wait.
Whatever her last name is now.
I'm
sorry.
Brandon, do they have biology homework?
It's great.
Is that loud?
Homework?
It's great. I put it on that. It's, I know you.
Hey, as soon as I see
Should I ask you that?
You beat everyone that.
Then you be quiet.
I didn't say anything mean. I'm kidding. Calm down.
Dude, we gotta finish it.
Why don't you say it?
Actually,
That's it.
actually,
I worked
I still need to get my background checked. My mom will be coming in when you work.
Good luck.
Well,
Well, I think she goes in at 6. Well, how are you working?
That Mountain Dew.
Yeah, my mom will be there. She'll probably yell at you.
Does anybody have a piece of gum?
My mom will probably yell back. My mom's like, I'm surprised she
John, I
hasn't.
thought you were my kid. Like a boy, you're on my kid.
She got someone else. Well, she didn't get someone fired.
I didn't know John Doe was here. Seriously?
They got wrong.
Was you not?
I seriously do.
I love those things.
Hey, Raven.
What is it? Do I get the extra? Taste the rainbow. That's sick. Oh, there's an Oreo in there. Every speaking of.
I'll take that Oreo.
Just put them in your hand.
Quit looking at my.
Put them in your hand.
I cannot. Eat these out of the jar. Exactly.
Yeah, I see them.
Was it Dollar General?
Until he comes in.
Kidding, I'm like,
I just feel like John.
But it might hurt.
You know what I mean.
You know what? We did not win one time.
Yeah, but I didn't.
We did not win one time.
He ain't in here yet.
he ain't in
don't care.
Hey, John.
The only thing I have to do is get a background check still. The only thing I have to do is get a background check still.
Well, technically, you can't really get a background check when you go there, and then you'll ask them what to give it to them.
Yeah, I'll help.
16 to make it, blah, blah,
We only got 5 minutes now, no talking. Crossword. Oh, yeah.
Was that the homework on this? You know,
Get that. Get that packet done, and get that into it, right? Gonna get all the other stuff that you're missing into me, figure out what you're missing, get it in here. Follow and move. Jeremiah, Monday?
Monday, Tuesday, and
Were you doing like a packet for the test?
I don't know. Depends on the class.
a lot of people, on my class. Yeah.
Depends on the class.
I was doing it.
I liked Abigail's class, so for them, yes, I did some.
Good.
That doesn't set well for some of the other classes.
Art classes.
We'll see. So Levi, would you come in here next week? I'm recording on this crap. We got to shut that off.
Here you go.
Come in here next week. Tell everybody. Everybody would.
Be nice to you.
Tell Eversource.
Who do you think?
Tell Eversource.